look at some linear functions, some linear equations. You notice I've already got one colored on a little bit. We'll do the second one. This is writing the point-slope form of the equation of a line. Can I get a quick read? Thumbs up, point-slope. You can totally do this. It's easy. I can do it in my sleep. Sideways, you'd like a quick walkthrough. Vote now. And remember, if you do not vote, I assume you are thumbs up. Thank you, thank you. All right, I do see quite a number of sideways thumbs. So let's go ahead and let's walk through number 2 together. All right, so we've been asked to write this in point-slope form. Point-slope form looks something like this. And once again, I'm going to use my color coding system so that you can see what everything is. So the items in black are static, they're not going to change, but everything else in a color is what can be substituted in for. So this makes it very clear for you to see that you can only substitute in for the value of the slope, which is represented by m, and the value of one of the point's coordinates, x1, y1. Now you have to choose which point is x1, y1, and you have 2 points to choose from, so pick one. Which one do you want to be x1, y1? The first point or the second point? The first point, says Maria. Maria is absolutely right because she made a selection, not because that's the one I secretly wanted you to pick. Do we have a slope? No. Can we calculate a slope? Yes. So let's calculate a slope really quick. I'm going to do that out here off to the side, and we're going to need an x1, x2 and a y2. So I'm going to create those very quickly, x2 and y2, and I'm going to go ahead and start my substitution. Again, using my color coding system as a way to help you keep track of where I am doing all of my substitutions. Got these double negatives. I'm going to go ahead and get rid of those double negatives now. And when I simplify this down, I end up with a slope of 1. Feeling okay with this one? All right, so now I have a slope of 1, and I've been given x1, y1 coordinates, and I am going to substitute. Ooh. Pens clattering everywhere. Again, a lot of double negatives happening, so take a moment to clean up double negatives. And so my new equation would look something like this. Do I need the 1 in front of the parentheses? No, because if I were to do the distribution that those parentheses are requiring of me, I would have 1 times all the stuff inside the parentheses, which doesn't change the parentheses, and so I can further clean up this equation so that it looks like that. And it's in point-slope form because all you've got in here is a point and a slope and nothing else. Make sense? Feeling okay with this one? All right. Let's look at questions 3 through 4. This one's asking you to write the slope-intercept form of a line, and they're giving you a point and a slope. Quick vote. Thumbs up. You think you know exactly how to do this. You're feeling really comfortable. Thumb sideways. You know what? You think you know how, but you want to see a walkthrough anyway. Thumbs down, you're completely lost. Vote now. Remember, if you don't vote, I'm going to assume you're a thumbs up. Okay, I see quite a number of thumbs sideways. Let's go ahead and make sure that we're feeling comfortable with this one. Now I have this one marked already for you. We want this as slope-intercept. So when we're done, we want our equation to look like this. And I got a lot of text messages over the weekend, and thank you those of you who reached out to me asking, how do we find the b? You know where the slope is, it's given to you, but how do you find that b? We've got two methods, and I'll be happy to show those both to you. The first one is going to be using the information you've been provided to. You've been given a point, and you've been given a slope, which means which equation do you have all the information for? The one we just finished, right? Yeah, point slope. Yeah, Maria was there about to say it. She was like, I totally have all the information for this. So I'm going to go ahead and substitute into this equation because I don't have to think about it. It's already given to me. And now I need to make this thing look like that. The easiest way to make that happen is just to solve the equation we have in front of us for y. Get rid of those parentheses, get y all by itself, we're done. B will magically appear in that process, okay? And that's what I'm going to show you how to do right now. First thing I'm going to do is get rid of these double negatives. Oops. Okay, the color was the only change that I made. I don't like fractions. Do you like fractions? I don't like fractions in an equation, so I'm going to get rid of fractions in an equation. How do I get rid of fractions in an equation? Multiply by what?
The denominator.
By the denominator. If we multiply by the fraction reciprocal, we have the chance, depending on what the fraction looks like, of creating more fractions, and that's totally not what we're trying to do. We're trying to get rid of the fraction. So multiplying by the denominator is the only surefire way of getting rid of the fractions in an equation. So thank you for that input. So there I'm multiplying everything through by 4, which is the denominator of this fraction. That's going to leave me on this side. With that, I distributed. And then on the right-hand side, this 4 is going to get rid of this 4, which means that I still have this negative 1 sitting out here that I have to deal with. But that's just a distribution thing, isn't it? With this negative 1? Yeah, totally distribution. So we're going to do that. We're going to distribute. So the right-hand side becomes something like this. The left-hand side remains looking like that. And now we're getting closer. Remember, our goal is to get y all by itself. So negative 8, I'm sorry, you've got to go away. Goodbye, negative 8. That's going to leave me with the 4y by itself on this side. And a plus 7 over here. So far, so good? Got to get rid of the 4, though, because remember, we want y all by itself. Nothing near y. So how do I get rid of the y? Divide. Because right now between the 4 and the y, we have this unseen multiplication happening. And so to get rid of multiplication, we need to do its inverse. We need to do its opposite. We're going to divide. Which totally doesn't look like the thing that we want. We want two things. We want the x separate from the numbers. So we're totally going to do that. Everyone feel comfortable with how I did that one? We're okay with this? All right. But we want some number times x plus stuff. So I'm going to rewrite the first term that way. Is everyone okay with how I wrote that, or do you want to see how I got from this to this? If this move right here, where the orange arrow is, if that move right there seems like magic, give me a quick nod, and you want to see how it's done. Okay, I've got a couple nods, so let me show you the magic so that way you can be a magician too. All right, I have this. I can rethink of this negative x as negative 1 times x, yes? Right? Can totally think that? And I can think of 4 as 4 times 1. With me so far? Now, when you have fractions and you've got multiplication happening, you can totally break the multiplication or the fraction at the multiplications. You're totally allowed to do that. The moment you do that, we now have this 1/4, and x over 1 is the same as x. I don't have to write the multiplications. Make sense? The magic is revealed. Dun, dun, dun. All right. Feeling better about this one? Yes, ma'am. Yes, that was the next one I was about to ask. Whoops, some people are still writing. I'm sorry. All right, so the rest of the back of the page is, again, more SlopeIntercept. They're giving you different starting setups. Again, you're using kind of all the same techniques. The request was standard form, yes?